Welcome back to Bizarre Creatures, where we must once again venture into the perpetual mist of the humid cloud forests, a specialized, high-altitude ecosystem to fully comprehend the shocking biological transparency of a creature whose survival depends entirely on the laws of light refraction. The breathtaking glass frog Centralenity, a tiny arboreal amphibian rarely exceeding 3 centimeters, has developed a biological camouflage so extreme that its entire ventral surface is translucent, allowing us to directly observe its internal organs, including its rapidly beating heart and complex digestive tract. In real time, the shocking truth is that this absence of opaque dermal pigment chromatophores creates a sophisticated form of cryptic coloration that prevents predators from visually defining the frog's solid outline, making the animal appear as nothing more than a blurred, indistinct spot of light and shade against the leafy background. The glass frog enhances this near invisibility by performing an unparalleled physiological feat, which involves manipulating the most color-dense and opaque component of its body, the oxygen-carrying red blood cells, which are rich in hemoglobin during its crucial daytime resting period. The frog consciously initiates an incredible process to remove approximately 90% of its circulating red blood cells and temporarily, yet safely, packs them into a specialized, tightly stacked compartment within its large, trilobed liver. This specialized blood sequestration mechanism dramatically reduces light absorption and scattering across the frog's body, achieving maximum tissue clarity while it rests. Yet remains a profound physiological mystery regarding its prolonged tolerance to such reduced oxygen-carrying capacity. As night descends and the frog transitions into its active phase, the sequestered red blood cells are instantly released from the liver reservoir, flowing rapidly back through the bloodstream to power the muscles needed for its precise nocturnal hunt. Its foraging is highly specialized, consisting mainly of tiny, slow-moving invertebrates such as beetles, spiders, mites, and soft-bodied arthropods, which it expertly catches high on the wet forest leaves using targeted ambushes and its long, powerful, sticky tongue. The glass frog's reproductive cycle introduces another shocking truth about its life history, as it showcases an extraordinary and unwavering level of dedicated male parental care, a rare trait among amphibians. Immediately following the clutch deposition, the female carefully attaches a small cluster of around 20 to 30 jelly-like eggs to the underside of a smooth leaf, ensuring the placement is directly over a flowing stream or creek below, providing the essential, unobstructed path for the inevitable drop of the hatched tadpoles. Once the female departs the breeding site, the male glass frog immediately assumes the critical role of guardian, relentlessly guarding the clutch for up to 2 weeks against numerous threats, including fungal pathogens, parasitic FLIs, and predatory wasps. The male's critical duty involves actively transferring moisture by pressing his ventral skin against the jelly mass to prevent fatal desiccation, and in several documented studies, he has even been observed urinating directly onto the eggs during periods of extreme atmospheric dryness. This constant paternal vigilance is absolutely vital for the survival of the offspring, as the eggs are highly vulnerable to both fungal infection and consumption, highlighting the extreme selective pressure driving this dedicated parental investment. After roughly 2 to 3 weeks of rigorous fatherhood, the tadpoles finally breach the jelly coating and perform a dramatic, chaotic, free-fall descent from the leaf into the cool, rushing water below. Completing their aerial phase, the stream provides their next sanctuary. But instead of swimming openly, the tadpoles immediately dive down and burrow deep into the sediment at the bottom of the creek. Finding protection from waterborne predators, they spend several months concealed within the dark mud and silt, feeding on organic debris, slowly growing and maturing before finally undergoing metamorphosis, the radical transformation into their adult form. Eventually, they emerge from the water as tiny, fully formed, miniature versions of the adult, ready to climb back into the dark, mist-shrouded forest canopy to begin their bizarre, transparent life cycle. Once again, the glass frog is a creature whose entire existence is a series of astonishing physiological and evolutionary trade-offs, continuously negotiating the stringent visual requirements of camouflage with the non-negotiable biochemical necessities of life-sustaining oxygen transport. The detailed study of the glass frog's unique blood sequestration mechanism has directly inspired breakthroughs in the field of biomimetics, prompting engineers to design advanced camouflage technologies and driving medical research into temporary blood storage solutions. Its life proves that nature's greatest genius lies not merely in the creation of complex colors and patterns, but in the radical, elegant act of strategically removing pigment entirely to achieve the ultimate functional form of survival. This stunning biological marvel, however, remains exceptionally vulnerable, as it is highly sensitive to minute fluctuations in air and water quality, making it a critical indicator species for ecosystem health. Their complete dependency on pristine, high-altitude cloud forest streams makes them critically susceptible to environmental stressors, including rapid climate change, widespread habitat destruction from agriculture, and illegal logging operations. Furthermore, like nearly all specialized amphibians worldwide, they are severely threatened by the devastating chytridiomycosis fungal disease, which attacks the skin and has caused catastrophic population declines globally. Conservation efforts are now urgently focused on preserving the delicate microclimates and pristine water sources of the tropical ecosystems they inhabit to ensure this transparent marvel does not functionally disappear from the planet. The glass frog is truly a living biological jewel that compels the scientific community to constantly re-evaluate the limits of animal adaptation, biomechanical engineering, and biological possibility in vertebrates. Its life is an eloquent testament to the immense power of evolution, showcasing its ability to exploit even the basic laws of light, physics, and visibility for the singular, unrelenting goal of survival. What an incredible journey into the heart of extreme camouflage, where we've witnessed invisible blood, exposed organs, specialized parental care, and a biological mastery over light itself, the physiological mechanism by which this tiny creature can safely and repeatedly remove 90% of its own oxygen-carrying blood remains one of the greatest and most compelling unsolved mysteries of its existence. Which specific part of this frog's radical adaptation, the extreme blood sequestration, the specialized skin clarity, or the dedicated paternal vigilance do you find the most profoundly shocking and scientifically challenging? We must continue supporting the essential research and conservation efforts to ensure this magnificent, nearly invisible species continues to thrive for generations to come. Serving as a biological blueprint, the glass frog is a creature whose entire existence is a stunning paradox, constantly negotiating the risk of exposure with the imperative of survival. Its incredible body provides a living, natural model for advanced scientific studies in areas ranging from non-invasive internal medical imaging to military camouflage. The sheer complexity and delicate balance of its biological systems underscore the necessity of rigorously protecting its unique and fragile environment from all human encroachment. We should marvel at the elegance of a creature that solves the fundamental biological problem of visibility by developing a genetic mechanism to erase its own color and outline. The glass frog truly is a shocking truth, visibly demonstrating the physiological and evolutionary extremes that life can achieve for the sake of survival in a hostile world. Tell us your thoughts and theories on the frog's astounding oxygen tolerance and metabolic regulation during the blood sequestration process in the comments section below. To support our mission of documenting these bizarre and threatened creatures, Please hit the like button on this video and share it with a friend who appreciates natural history. If you dare to delve deeper into the most extreme and cryptic secrets of the bizarre world, make sure you don't miss our next upload. We cover the animals whose existence fundamentally challenges the very laws of science and adaptation. Offering profound insights into biological engineering, hit that subscribe button and ring the bell to join the Bizarre Creatures family for more shocking, in-depth truths about the natural world.